Okay, I'm going to apologize. I've already done this numerous times. And so we are going to be talking about the atomic structure of the atom. And we do know we have major subatomic particles, the protons, neutrons, and electrons. Protons are positive, neutrons are neutral, they have no charge, and electrons are negatives. There are also particles called quarks, and they are what protons and neutrons are composed of. So let's look at the mass of an atom. How do we get that? The atomic mass unit is how we measure the mass of an atom. It is referenced as 1 AMU, and it's equal to 1/12 the mass of a carbon-12 atom, 1.66 times 10 to the negative 24 grams, the mass of a proton or a neutron. Now carbon-12, that's its mass, 12, has 6 protons and 6 neutrons. So we look at the mass number, which is the number of protons plus the number of neutrons. So that's how we get the 12, from 6 protons and 6 neutrons. The electron's mass is considered to be 0, so it's not considered or helps compose the mass number. We are only focusing on the nucleus, and carbon is our standard for doing that. Every element has a different number of protons or atomic number. Keep in mind the number of protons equals the atomic number, and that's how we determine what element we actually have. So every element has the same number of protons or atomic number. They are one and the same. However, there are atoms of an element with different numbers of neutrons, and we call those isotopes. So every atom has the same number of protons, but may have different numbers of neutrons, and those make isotopes. And we said that the protons and neutrons, or the mass of the nucleus, gives you the mass number. So if we have different neutrons, we have a different mass number. There's also ions, and those are atoms that are not neutral. So generally when we speak of atoms, we speak of them in the neutral state, so they have no charge, and that means the protons are equal to the electrons. It has a different amount of electrons than protons. We are dealing with an example of ions. We can lose electrons. So here we have sodium, symbol Na, with 11 electrons and 11 protons, and we lose 1 electron. We now have 10 electrons and 11 protons. This symbol is Na with a positive charge, so we write that as a superscript, as a plus. Often I write it as +1. I don't want any questions on if I forgot to write something or if my handwriting is messy. So I do usually write the 1 after it. You may choose to just use a plus, but be careful on your handwriting. If we look at chlorine, on the other hand, it has 17 electrons, 17 protons. It's going to steal that electron or that missing floating electron from sodium, and now it's going to have 18 electrons and 17 protons. That symbol now has a minus. Keep in mind, electrons are negatively charged particles, so if we lose something negative, we become extremely happy, and so we are positive people. If we gain something negative, like chlorine did, then we start to feel pretty yucky, and so we have a negative attitude. So chlorine becomes negative because it gained an electron, that negative energy, and sodium becomes positive because he lost that negative energy, and so now he's happy. When those two elements, when that occurs, we get sodium chloride or table salt, NaCl, and that is something we'll discuss when we do bonding. So the two words, let's look at those again. Ion, we have the same element, meaning the same number of protons and atomic number, but we have a different amount of electrons. Isotope, same element, same number of protons or atomic number, different number of neutrons. So for vocabulary, in short, I remember ion, electrons, isotope neutrons. This slide is one slide out of order. So we're looking at nuclear notation. It is a format we use to describe isotopes, and I learned it as isotopic symbols, so I may actually use that word here and there, but they do mean the same thing. We're looking at what's inside the nucleus. Our most common isotope is hydrogen, and we have our symbol. So we have the H. You can look at your periodic table. It's in the upper left-hand corner. It is our very first element. And it has the mass number of 1 and the atomic number of 1. Now the mass numbers are rounded numbers, and keep in mind we have the average number of all isotopes as our our atomic mass on the periodic table. We can round that and have a mass number, or a mass number will be given to us. So in this case we have deuterium. The mass number is 2, and the amount of protons is 1. There is no charge here, so our electrons are also 1. We can subtract the atomic number from the mass, and we will get its neutrons. So this has 1 proton and 1 neutron pictured for the nucleus. Our next isotope is tritium or tritium, and this one has the atomic mass of 3 and the atomic number of 1. And if you look in the image, you see that there is 1 proton and 2 neutrons. So we subtract 1 from 3 and we get 2. Once again, there is no charge, so the electrons are equal to our protons. So let's review the symbols of an isotope. And this is it is the same element that we had before at the end of our atom history notes. Our symbol is Pt, so we're dealing with plutonium. We can look that up, and that's a symbol from the periodic table. We can look at the mass number, 197, so either that would be given to us in a problem, or we can round the number from the periodic table. And we can also look up the atomic number for plutonium is 78. So what we need to look at is the protons and neutrons, because after all we're talking about isotopes and it's dealing with protons and neutrons. This isotope has 78 protons directly from the atomic number, and to determine the neutrons we will subtract the 197, we'll subtract 78. So 197 minus 78 gives you 119 for neutrons. All elements have a variety of isotopes. There is a brief notation form, so we have a shortcut for our little symbol. And in this case, we're looking at uranium. Its symbol is capital U, and the mass we're given is 238, so that's the mass number. Either we're taking it from the periodic table and rounding it, or it would be given to us. So from this notation, we can look up uranium on the periodic table. It is element 92. And the mass number was given to us, 238. So if we subtract 238 and 92, we get 136. So we have 136 neutrons. Notice we have no charge in the symbol or shown in the symbol, so once again we are neutral. So we have 92 protons and 92 electrons. So for mass number, we want to find the atomic mass on the periodic table of our given element or atomic number that's given to us. We could also be given protons, because that's the same as atomic number. We can find the average of all the isotopes by weight. That is written underneath this symbol, and it does have decimals after it. So if you look at hydrogen, it's 1.00 something, and then we have helium, and then we move on, so the mass is increasing for every element we go to, it gets higher. There are 2 discrepancies in the periodic table, so maybe you can spend some time looking for those. And we want to take that number and round it using the regular rules of math to the nearest whole number. And that will give us the mass that we're using. In class or on a test, we could be given various pieces of information within the symbols. and be asked to pull other pieces from that. So we will do practice with data tables as well as just open-ended questions. So this is something we will practice in class as well as understanding ions. Have a good night, and I'm hoping this fourth try or fifth try actually works.